Good morning. Bad sunlight. Bad light. Good morning, scholars. Welcome back to our next installment, which would be determining the intersection points of different polynomial functions, both algebraically and graphically. So basically, taking it back to Algebra 1, solving systems of equations, but involving quadratics. So I can calculate the solution to a system of polynomial equations, and I'll know I've got it when I can find where two polynomial functions intersect. In X marks the spot, without graphing, Lewis attempts to determine algebraically the points of intersection between these two polynomials. Describe Lewis's solution path. Would you follow that same path, or would you make an adjustment? What adjustments, if any, would you make and why? You can copy and paste both of those functions into our text box using the square root button. So you can type math type and detail your specific strategy and if it aligns or goes against what Lewis was doing. So over the next slide, you have a few polynomials given to you, to which you need to find their points of intersection. If you have forgotten, graphically, a point of intersection is the equivalent of the algebraic equal sign. Simply setting equation, or the polynomial, equal to one another and performing the correct algebraic manipulations. Already jumping the gun. Plus 9 plus 7. This 2 plus 7 will give us 9. And obviously, taking the square root of both sides yield me correct solution. Make sure that you double check. I'm going to use Angie's little hack here, right? Slash PM plus and minus 3. Right, so make sure you double check that your solutions work. 3 squared is 9 minus 7, which will give me a 2, and negative 3 squared will give me a positive 9 again, minus 7, and yield a 2. So those are the two intersection points for this particular function. But as always, things might not necessarily be the same for our next 3. In our last 2 slides, you are provided with a graphical representation, and as I had mentioned earlier in this video, graphically we are looking for the point of intersection. Intersection is where two functions are crossing. So here we can see the value of x that makes this polynomial equation true is 10. For the x value at the point of intersection, what can we say about the value of this particular function? That function is modeled here. That is our red function. After you determine what you can say about the red function, what does that information tell you about a possible factor of that particular function? And then I'd like for you to spitball some dialogue with your classmates about how can we prove a value is a factor of a polynomial, as that is going to be the content of our lessons over the next 2 to 3 Desmos activities. And at that point, take a 30-second timeout on the coach. Pick it up in class.